The first derivative will tell us where it's increasing or decreasing. The second derivative will tell us about concavity. Let me give you a quick rundown of what all that means. I'm going to make something up. Okay, let's suppose that's our function. Let's not even draw the axes here. It is decreasing, then it is increasing, and then it is decreasing. Okay, concavity deals with whether or not it's open up or open down. Let me get really wordy here. Concavity deals with whether or not it's increasing at an increasing rate. Notice the shape of my hands. Whether it's increasing at a decreasing rate, whether it's decreasing at an increasing rate, or decreasing at a decreasing rate. Think about that. Rewind the video if you need to. It'll kind of make sense. Anyway, concavity, this part's concave up and that part's concave down. And that's a second derivative issue. So we're going to be dealing with the first derivative and the second derivative. Let's erase this random curve that has nothing to do with that function. Let's actually write f of x up here. And let's start. Okay, the first derivative tells us whether or not it's increasing or decreasing. So we're going to take the derivative. This is a very easy one, 2x plus 2. And we're going to set it equal to 0. X is equal to negative 1. There is a potential point, called a critical point, where it could be increasing then decreasing or decreasing then increasing, where it changes the direction. So we're going to draw a number line and we're going to put a negative 1 on it, and just for fun we'll put negative infinity and we'll put infinity, and that negative infinity looks like a really deformed canoe. We need to plug in a number. We're going to do this in our head. I'm not going to write all this down. But we're going to plug in a number somewhere in this interval into the first derivative. Plugging it into the derivative tells us the sign of the derivative and tells us whether or not it's increasing or decreasing. So what we're going to do is plug a number, for example, negative 2. F prime of negative 2, and then we're going to plug in f prime of something in this interval. 0 is always an easy one to go for. F prime of negative 2 is, well, negative 2. I don't care that it's negative 2. I care that it's negative. Plugging in 0 gives us a positive. What that tells me is this. First derivative tells me about increasing and decreasing. It is increasing on the interval from negative 1 to infinity. It is decreasing on the interval from negative infinity to negative 1. That is great. Let's talk about concavity now. Concavity comes from the second derivative. The second derivative of this function is the derivative of the first. 2x plus 2, derivative of that is just 2. We'll write something illegal here, then I'll fix it very quickly. We set that equal to 0. What? No, can't happen. Normally, if we could solve this, we would, and in the process of solving this, we would come up with a critical point. That critical point would go on here. I just said the wrong word. Point of inflection. The point of inflection is where the concavity potentially changes. Critical points, points of inflection. Okay, wanted to clear that up. It would give us the point of inflection, almost said it again, give us the point of inflection where the concavity would potentially change. And we would do all kinds of fantastic stuff dealing with signs. That almost looks like an 8, like the 8's laying down. And we have a positive 2. Okay, don't do what I'm about to do. Don't do that. That is not where x equals. That is the actual value of the derivative. That is illegal. Don't do that. Here's the point. That's a positive 2. We don't have any intervals. We have an interval from negative infinity to infinity. And so intervals where it is concave up, there are none of those. We can just not even write that if you don't want to. But concave down, there is an interval from negative infinity to infinity. I just said that whole thing backwards. I'm not going to redo this video. I apologize for what I just did. It is late and I am tired. Let me fix this. Because it is positive. You probably caught it before I did, because you have more sleep than I do. Because it's positive, it is concave up from negative infinity to infinity. Concave down nowhere. I'm sorry. My apologies.